This video will show you how to use the calculator to solve a system of equations with three variables. Specifically, you will input a matrix and the calculator will process the matrix into reduced echelon form. In this form, you will be able to do back substitution to solve for the unknown variables. Example 1 will have one solution. Use a matrix in reduced echelon form to solve the following system of equations. X minus 2y plus 2z equals 4, 2x minus y minus 5z equals 5, and minus x plus y plus 4z equals 9. Now let's input these into the calculator. So remember, we go to second function in matrix. Now recall from the video matrix dimensioning and editing, we had already inputted a matrix for A and B. So that's why we see these already here on this screen. We can delete them or we can just change the dimensions and then edit them. So let's recall how to delete them. We go to second function and mem. We go to number 2, mem management, delete. So number 2, and then number 5 for matrix. And let's say we just want to delete matrix B. So if we move down to here and select the delete key, then we can go back to the matrix screen, and now you see we only have matrix A. Alright, so let's see how we would change this particular dimensioning here. So let's go to edit and select number 1, or we can just hit enter. Okay, now for the reduced echelon form, we're not only going to input the values of the coefficients on the left-hand side, but we're also going to include the constant values on the right-hand side. So we need to make this a 3 by 4 matrix. That's 3 rows by 4 columns. So let's change this to a 4, select 4, and then enter. So now we need to change the values. So let's go ahead and start this. But first I would like to make a note, and that is in the calculator's mode setup, the float is set to 3. And this is why you see the coefficient values of the system of equations rounded to 3 decimal places. Now, if you wanted to preserve a little bit more room on the screen, you would set the float to 0, and it would just show your integer values. And this would give you more room on the screen, and we wouldn't have to scroll all the way to the right to input the constant values. So I just wanted to bring this to your attention. So the first one is 1, that's okay. The next one is minus 2, that's okay. The next one's 2, that's okay. And then we need to change this to 4. So we select enter. And this value is fine, this value is fine, and this value is fine. So we need to move over and change this to 5. Select enter. And this value is okay, this value is okay, and this value is okay. Remember, these are all okay because we did this in the video matrix dimension and editing. So let's move over and input 9. Select enter. Okay. So let's get out of this. Let's go back into matrix. So there we have our 3 by 4. And let's go to math. And we'll move this down till we find REF, which means reduced echelon form. And there it is, option A. So let's select enter. Now we want reduced echelon form for what matrix? Well, we called it matrix A. So we go back into matrix, select this one, So enter, and then we close the parenthesis. Now let's select enter, and here's our matrix in reduced echelon form. So if you look to the screen to the right, you will see the system of equations now corresponding to this matrix. So you can see 1 means x, negative 0.5 is negative 0.5y, and then negative 2.5z, and that equals 2.5. Okay, and let's move over again. Let's look at the second row. So the second row says there is no x variable, so it's just y. Subtract 3z, and that equals negative 1. And then finally on the third row, we have no x's, no y's, and z, or 1z, equals 4. So now with back substitution, in other words, we take z and then we substitute it into the equation that says y minus 3z equals negative 1, and we solve for y, we'll get our y value, and then once we have our z value and our y value, we substitute that into the top equation, and then we'll end up solving for x, and we have our final solution. So with back substitution, you can solve for y and then x. The final solution is shown also on the screen to the right. Let's go to example number 2. First, let's clear the screen. Example 2 will have no solution. So we want to use a matrix in reduced echelon form to solve the following system of equations. X minus 2y plus 3z equals 4. X minus 5z equals negative 2. And 4x minus 6y plus 4z equals 14. Okay, let's input this system of equations into the calculator. So second function and matrix. Alright, so here's our matrix. It's already in the dimensionings 3 rows by 4 columns. So let's go ahead and just edit that. So I'll select enter. Now let's just change these values. So for the first one, 1x, that's fine. Minus 2y, that's okay. And this needs to be a 3 for 3z. So change that to 3, select enter. And then equals 4, that's fine. So let's move down. So there is 1x for the next system. Select enter. There are 0 y's. Select enter. And negative 5 for the z value. And finally, the constant is negative 2. Select enter. Alright, and then we have 4x. Select enter. Then minus 6 for the y. And then 4 for the z, that's fine. And then we move over, and that should be 14. Select enter. So let's just verify that these are all correct. So 4, 3, minus 2, and 1, that's fine. And 1x, 0y, minus 5z equals minus 2, that's fine. Then we have 14, 4, minus 6, and 4. Looks good. Okay, now let's go through the same process that we did before. So let's quit out of this second function, quit, go back to the main screen. Alright, So you need to go back to the main screen to actually do the matrix operation. So second function, then matrix. Let's go to math. And let's find REF. There it is. Select enter. Let's go back to the matrix mode. And we want matrix A. Select enter. And close the parenthesis. And then enter. Okay, here's our matrix in reduced echelon form. All right, so this matrix represents the system of equations to the right, and it says that 1x minus 1.5y plus 1z equals 3.5. See right there. And then the second equation says there are no x's, but there is 1y and subtract 4z, and that is equal to negative 3.667. Then the final row, which says 0 x's, 0 y's, 0 z's equals 1. So when we have 0 is equal to 1, that's inconsistent. It doesn't make sense. How could 0 equal 1? Well, it doesn't. So therefore, this tells you that there are no solutions for this particular system of equations. So you would just write down no solution. Okay, so our first example had one solution. The second example had no solution. And now when we go to example number 3, this will have infinitely many solutions. Okay, so let's go ahead and clear that screen. Okay, so example number 3 will have infinitely many solutions. Use a matrix in reduced echelon form to solve the following system of equations. X subtract 3y plus 2z equals 1. Negative 3x plus 7y equals negative 11. And x minus 4y plus 5z equals negative 3. All right, so let's input the system of equations here. So second function matrix. And again, we want a 3 by 4. So we go over to edit. And number 1, select enter. Let's just change these values. So we have 1x is fine. We want this to be negative 3. Enter. And then 2. Enter. And then 1. Enter. Now, negative 3, 7. There are 0 z's. Okay. And we want this to be negative 11. Enter. 1 for the x. Negative 4 for the y. And 5 for the z. And then negative 3. Enter. Okay, so let's check these values real quick. 1 minus 11 minus 3. We have 2 for the z, then we have 0 for the z, and then we have 5 for the z. That's good. We have minus 3 for the y. We have 7 for the y. Make sure that's a positive 7, yes. And then we have minus 4 for the y. We have 1 for the x, negative 3 for the x, and 1 for the x. So everything looks good. So we're ready to do our computation. So let's go into the matrix mode, second function matrix. Now remember, we want to go over to math, but we need to get out of this screen completely to use this operation. What happens if you don't? Let me just show you. If you go over to math right now and you go to REF, See, it takes you back into the matrix that we're looking at. So we're trying to put in the cell. This is row 3, column 1, which is right here. It wants to put in that operation REF, which doesn't make sense. So remember, we need to completely quit out of the matrix mode. So second function, quit. Okay, let's clear that. And now we would go into second function matrix, and then you go to math. And then now we want REF. So you always want to start your operation from the main screen. So there's REF. Select enter. And we want second function matrix. We want matrix A. Select enter. Then close the grouping symbol and select enter. Okay, now one thing I want you to notice, and that is that the cells have some decimal places. This, for example, negative 2.333, that could be written as a fraction, negative 2 1/3, right? So let's move over a little bit, and here we have some more decimals here. So what's really nice is you can get the exact values for each cell. Now recall, one of the videos showed us how to convert decimals into fractions, and we can do the same thing with the matrix. So let's go back and recall our last operation, and to do that we go to second function and then hit the entry here. So select enter. Okay, now what we're going to do is put the fraction operation here. So what we're going to do is we hit the math button and we want FRAC. Select enter and then enter again. And now notice it took the decimal and converted to a fraction. So let's look at this value here, the 3.667. Let's move over. And that converted it to 11/3, because this is 3 2/3, which would be 11/3. So these are the exact values. It's better to have that. Now I would like to show you a little bit faster way to convert your matrix that involves decimals to fractions. Now recall what we just did. We went ahead and we computed the reduced echelon form of matrix A, and we realized that those cell values involve decimals, and we wanted to convert those to fractions or exact values. And what we did is we recalculated that matrix in reduced echelon form. Then we went to the math button and chose the frac and then selected enter, and we got our fractional values. So this time we're going to make the steps a little bit shorter. So let's go through those steps. Now let's go back to matrix, so second function matrix, and we want to go over to math, and we want to compute the reduced echelon form of this matrix. So we'll scroll down till we find REF, and there it is. So we'll select enter, and then we go back to matrix, so second function matrix, and we want matrix A, so we select enter, and then close the parenthesis and select enter. Now here we can see that there are decimals. So right now you can just simply go to math, and there it is, frac, and select enter, and then enter again, and right there it converts all of those values that were in decimal to fractions. So you can see here negative 2.333 and so on is at negative 7/3. Okay, and you can see the other cell values that were converted to fractions. So that's just a little bit faster way to go from your cell values, which are decimals, to fractions. So now if you look to the right, we have our system of equations for this reduced echelon form. and we have 1x minus 7/3 y. There's no z value, so you don't list it, equals 11/3. And the second equation is going to be, well, there's no x, you don't put it down. It's going to be y for 1y and negative 3z right there, and that is equal to 4. Now, what's unique about this matrix in reduced echelon form is the third row are all zeros. 0, 0, 0, and 0. So that's a true statement. The left-hand side is equal to 0, which is equal to the right-hand side, which is equal to 0. Okay, so 0 equals to 0. This means there are going to be infinitely many solutions. So what you need to do is you need to set a variable equal to some type of a parameter. Usually you take the last variable, and the last variable here is z, and you set z equal to this parameter. So let's let z equal t. T is that parameter. Then you're going to use back substitution to solve for y, then x. So your answers are going to be written in terms of t. So when you do this back substitution, you end up with x equals 7t plus 3, y equals 3t plus 4, and of course z is equal to t. Now what you're going to do is you let t be any value that you want. This is where the infinitely many solutions comes in. So if we start out, let's pick an easy value for t. Let's say t is equal to 0. So if t is equal to 0, then x equals 3, y equals 4, and z equals 0. If we let t equal 1, then x equals 10, y equals 7, and z equals 1. And you can keep putting in values for t. Negative 5, negative 3, negative 1.4, negative 2/3. It doesn't matter what value you put in. All these values will work because there are infinitely many solutions for this particular system of equations. So now we've been through 3 possible situations. For the first example, there was 1 solution. The second example, there were no solutions. And the third example, there were infinitely many solutions. And remember that we used the reduced echelon form of the matrix to get our answers. So this concludes the video on using the matrix option and the reduced echelon form.